morning, scholars. I hope you're doing so well today. I miss you. I hope you had a productive and happy and healthy long weekend with your family, with your friends, while staying socially distant, of course, because that is important. That's something we're still going through. Um, and I'm really excited for class later today with you all. I missed you over the weekend. I'm also really excited because we're going to be jumping into a new math topic. This is our final math topic of the year, Module 6. Congratulations, we are in the final stretch, y'all. This is amazing. And this is actually one of my favorite math topics from when I was younger. Just a quick little story. Like a lot of you, when I was younger, I felt like I struggled with certain things in math. I had some trouble with fractions, I had some trouble with multiplication, and especially I struggled with division. And when we went on to graphing, I loved it because it's a really different type of math. You're still using numbers, you're still problem solving, which are all the important things that we do in math, but instead of using a lot of calculations, it's a lot of kind of looking at things and trying to figure out where something is on a line or between two lines, and I like it a lot. It's a different type of math, and I really hope that you enjoy it with me. So with that, let's get started. And so we're going to start with just a quick activity to warm up our brains for what graphing is going to look like. And as you can see here, we have these three number lines, and your job today is using these following tape diagrams. The tape diagrams are the number lines. Your job is to find the number that is equivalent to each letter. So you see we have A, B, C, D, E, F, G, H, I, and here we have A, B, C, D, E, F, G, H, I. And our job is to figure out, well, what is this B? Like, what number would this B be? What number would this C be? What number would this A be? And so I want you to notice a couple things, and we're going to start with this first number line. You'll notice that it starts, this number line here, we start at 0, we end at 10. And so we need to think about, well, how many spaces are between, how many notches or like little marks are there between the 0 and the 10, right? Like if there was 1, 2, 3, 4, 5, 6, 7, 8, ran out of room there, 9, 10. Oh, so do you notice how for each one of these we could assign it a number? Because we know how many jumps we need to take to get from 0 to 10. We see how many there are. So if this is 0, this could be 1, we could have this be 2, we could have this be 3, we could have this be 4, we could have this be 5, right, and so on. 6, 7, 8, 9, and it fits perfectly because here's 10, right? So I went all the way from 0 to 10. And so now when I look at B, I know that B is equivalent or the same as the number 2 on this number line. So I'm going to make sure that B is labeled with a 2. What about C? C is a 5, right? Because where the C is on this number line, it's halfway between 0 and 10, and B, we counted out each one of them, and we found that this is equivalent to 5, and A would be the same as 9. So that's how we work, that's how a number line works, that's how, something like this works. So the next one we're going to do, again, I want to look at what are my endpoints here. Here it's 0 and 1. So it wouldn't make sense for us to use the same numbers that we did here, where we said, okay, this could be 1, this could be 2, this could be 3, because if you look at the way it's spread out, it's only between 0 and 1. So we need to figure out, well, how many jumps are between this 0 and this 1? So here's 1, 2, 3, 4, and 5, right? In other words, I went 1, 2, 3, 4, 5. We know that 1 is equivalent to 5/5, right? That's the same as saying that I have, we'll just do one quick review here. If I have a candy bar and I cut it into 5 pieces, 1, 2, 3, 4, 5, and I eat all 5, 1, 2, 3, 4, 5, I've eaten the entire candy bar, right? So that's why 1 is equivalent to 5/5. If 1 is equivalent to 5/5, then I know the reason, by the way, I came up with fifths is because there were 5 jumps, right? 1, 2, 3, 4, 5. 5 jumps, so that's why this number, this bottom number, is going to be fifths. If that's going to be fifths, then this will also be fifths, but this will be 4/5. This would be 3/5. This would be 2/5. This would be 1/5. And this would be 0/5, which also, by the way, makes sense because if I have a candy bar cut into 5 pieces and I eat none of it, I've eaten no candy bar. So now, by doing that, we were actually able to figure out, excuse me, that this is cut into fifths, right? So I can now look at, okay, well, what's D, right? That's what our whole goal was, to be able to find the letters that are equivalent, what numbers the letters are equivalent to or the same as. D is 1/5 of the way down this line. It's 1/5, it's exactly 1 mark in, right? So D is going to be 1/5. And what I want to point out is that even though both this one here and this one here are exactly one like mark down their respective lines, the lines aren't the same amount, right? This one is between 0 and 10. This one's only between 0 and 1. So they're going to mean different amounts, right? Just because it's 1 mark down doesn't mean it's 1 whole. Let's look at what E would be. Well, E is this one over here. That's 4/5. So I'm going to say E is 4/5. And what is F? I look at F, I see it's equivalent to 3/5. All right, let's look at this last one. This last one here, it actually gives me an extra hint. It shows me what it starts at. It starts at 0. It shows me what it ends at. It ends at 5. But if you look here, this is a 1. This already tells me that this is going to be 1. How many jumps did it take to get from 0 to 1? It took 2, right? 1, 2. Because these have to stay consistent, because they have to stay the same amount, I know that every 2 jumps is going to be another 1. So if this was 1, then this one's going to be 2. And this one is going to be 3, because see what I'm doing is I'm saying here was like, to go from 0 to 1, I passed 1 mark and then I went. So here I'm going to pass a mark and I'm going to go there. And I'm going to pass a mark and I'm going to go there. And each of those is equivalent to 1 whole. And so here again, right, I'm going to pass this mark and I'm going to go here. That's going to be equal to 4. And that ends up working out, right? Now from 4 to 5, that is also 1 whole. So it worked out. Each one of these is, in fact, each one of these whole numbers is 2 down, is like 2 jumps, right? 1, 2, 3, 4, and 5. But now the question is, well, if this, and this are whole numbers, what are these going to be? Well, I see that there's only 1 between each whole number. And I know that this length and this length need to be equal, need to be the same. So what falls exactly between 0 and 1? Exactly in the middle, halfway between. Half. So this is going to be half. Now this one here, it falls right between 1 and 2. So it's also halfway between 1 and 2, and these need to be the same. But it's not just a half, it's 1 and a half. Why is it 1 and a half? Because it's 1 and then a half more. If I added another half to this, I'd get to 2. So it turns out that every big jump is 1 whole. That's not a 1. Is 1 whole. Every small jump, every one of these guys, is a half. This is a half, this is a half, this is a half, this is a half, and that works because 1/2 plus 1/2 is going to be the same as 1 whole. So here's a whole, right? 1 whole jump from 2 to 3, and I split it in half. This will be a half and a half. A half plus a half makes a whole. And this will be 2 and 1/2. So that's how we figure this out. So it's going to be your job to figure out what G, H, and I are based on what we've done here. And that's what you're going to submit, like in addition to these other things that we've done together. And yeah, let me know if you have any questions about that. Please come to office hours. Please ask during class. I love you. I miss you. And I will see you soon, scholars. Bye.